Hey everyone, and welcome to TensorFlow 2.0 Deep Learning and Artificial Intelligence. Now this is one of the most exciting courses I've ever made. I've been making these deep learning courses for a long time, before TensorFlow was even invented. So it's been quite a journey for me to see how this field has evolved in the past few years. And guys, it's been moving quick. The best practices and guidelines you'll learn in this course are the latest and greatest. This stuff did not even exist when some of my previous deep learning courses came out. Things like the best way to train your neural network to architecture decisions. Thanks to the hard work of deep learning researchers all around the world, I've been able to take what they've learned and bring that information to you. This course is designed to be a beginner to advanced course. So you don't need a lot of math and background knowledge, but of course, if you're into that sort of thing, I certainly have resources for you. We're going to start by looking at basic machine learning in the form of a neuron, the fundamental building block of neural networks. From there, we are going to jump right into neural networks, the thing that started it all. Luckily, with TensorFlow 2.0, you don't need a lot of heavy theory unless you want it. The TensorFlow 2.0 API was designed to be easy to use so that you can focus on building cool things rather than debugging and mathematical equations. Next, we're going to look at convolutional neural networks, which are specialized neural networks for computer vision. Then we'll look at recurrent neural networks, which are specialized neural networks for sequence data, such as time series, text, speech, and DNA. We'll even apply RNNs to stock prediction. This is one of my favorite exercises from this course because it teaches you what 90% of other people are doing wrong. If you've ever used an LSTM for stock prediction before, or taken a class that promised to teach you, you'll definitely want to watch this. Because TensorFlow 2.0 has such a simple and easy to use interface, it makes building extremely complex things much easier than they used to be. Here are some example applications. First, we have GANs, which stands for Generative Adversarial Networks. These are a new training paradigm which allow you to use deep learning to generate beautiful photorealistic images. What's absolutely crazy about this is that the images you are looking at now are of people that do not actually exist, but it doesn't stop there. Deep learning has been applied in the field of reinforcement learning, which excels at tasks that take multiple steps to complete, like playing a video game. Deep reinforcement learning agents have beat world champions in the strategy game Go and in modern video games such as CSGO and Dota 2. These are things we wouldn't have dreamed of just 10 years ago. Of course, if that's not enough, we still have more. Deep learning powers state-of-the-art natural language processing applications, such as speech recognition and machine translation. So whenever you talk to your phone and it figures out that you want to say, order a pizza, or set an alarm tomorrow for 6 a.m., that's speech recognition using deep learning in action. Neural machine translation has significantly enhanced the capabilities of language translation in the recent years. With students in 200 countries around the world, I've made use of this great technology more than once. And guys, I could go on. There's self-driving vehicles, object detection, facial recognition, deepfakes, synthesizing speech so you can have a phone conversation with a robot. So if you want to learn how to use the latest version of the world's most popular deep learning library, this course is for you. Thanks for listening, and I'll see you in the next lecture.